Hi, this is Jeff Blauette, technical agronomist with Cooperative Farmers Elevator. And on this week's Field Friday segment, kind of thought I'd discuss kind of what I've been seeing as I've been walking through our various test plots through our territory and how the corn looks in this. Obviously, we've had a lot of extreme weather in some places, lack of rain, plenty of heat, and I thought we'd kind of talk about what that's done to our corn crop. I got a couple of maps and things to show here just to kind of put a frame of reference for where we're at here. If you look at this map, this is showing the basically the water year from the 1st of October last year through current day. Kind of, after the 1st of October last year, last year's crop was done pulling water, so anything we got from there going into the soil would obviously be feeding this crop, hopefully. So you can see quite a variation. If you look at where Lyon and especially southern Lyon and Sioux County, as you get down towards that area, you can see they're probably 10 inches below normal in that time frame as far as precipitation goes. But you do see, and I've seen this in how the crop looks as well, as you start getting to the east and especially northeast in our territory, you look at where like northern Dickinson County is, actually probably 2 inches above normal, and I think you can see that in how the crop is reacting. So there's quite a variation within our territory, and I think as we get plot data out, and post it, you're going to see not only a lot of variation from area to area, but a lot of variation even within a specific plot. We've had a real heavy load of stress in some of these plots, and some hybrids are not going to flourish or not going to do well, and some are going to handle it much better. So there's going to be a big swing from top to bottom of plots, and probably a big swing from top to bottom if we look at the best performing plots and the ones that had the most moisture stress. So you'll see that as harvest gets here. But so if we kind of look at another frame here, what we have within our test plots, as far as if I look at our rainfall from basically May 1 to the current time, you get our plots in that northern Sioux County, southern Lyon County area. A lot of those plots are only running about 7 to 9 inches of rain in that time frame. If we look at what we get along Highway 9, northern Sioux County along the state line, that area has gotten some more rain, probably running anywhere from 12 to 18 inches of rain since planting. Lake Park probably is the high water mark, has had probably 18 to 19 inches of rain since basically the 1st of May, and you can see it looks better. All the stuff along Highway 9 is probably going to be our best performing plots, and it's all a water game. So it'll be interesting. We've seen it already in some of the silage that's come out and some of the yields that are out there. It's pretty variable, especially on the lighter soils. It's really struggled. The other facet of this that kind of comes into play is not only the moisture, but we have a measurement called stress degree days. So what a stress degree day is, anything that's above 86 degrees for over day high is kind of a stressful environment for that corn. The hotter we get, the more it goes backwards, you might say. Anything above 86. And it compounds. Actually, you probably don't really run into much stress on corn up to 90 degrees if it has adequate water and the roots can take up enough to cool itself. You can probably deal with it better. So when we get shortage of moisture and heat, it stacks on top of each other. If we look at a lot of our territory, especially to the west, but even to the east, as far as the temperatures we had, we're running about 300, somewhere in that range for stress degree days for the season. The number that's kind of used somewhat in the industry is 140 stress degree days. Anything less than that, you're going to have very good potential for above trend line yields. But obviously if we're above 140, it's going to take its toll on yields. And even in the areas that we look at where we have had adequate moisture, we see a lot more of this tip back going on, and it pollinated fine, but you can see it aborted, and it had probably more to do with the heat in those areas. And then of course it's even worse where we had heat and lack of moisture. So we're going to have probably a little lesser crop than last year. I think we all kind of expect that. It's going to vary within the areas, of course, how much it's off, but those are some of the numbers behind what we're seeing for the growing season and what we're dealing with. I'm in a field here. This is kind of in the Alvord area. just thought I'd look at some examples here. You know, a couple things show up in most fields, some obviously worse than this, but we've got a fair amount of tip back here. All these tips actually pollinated. You can tell by the kernels that were there and shriveled away. Not terrible here, but it did have, you know, a fair amount of stuff that we could have had better if we had better environment for the corn crop. The other thing that's going to be real common this year, as cool and cloudy as we were in May, we've got a lot more. This is a little smaller, a little late coming ear, a little smaller stalk. We've got several of those in here. The uneven emergence, you know, actually it's a decent little ear for a small stalk that obviously came up a couple days later. With the way our emergence was this year, we've got a lot more variable ear size. It's hard to find even in a test plot where we've got that nice ear-to-ear consistency. The other thing that we see a fair amount of this year with the stress, we've got these zipper ears. There's, you know, an area in here that pollinated a little bit less on the tip. That's the side of the ear that's hanging down. That bottom pollen is the last, or that bottom silk, I should say, are the last part of the ear that catches pollen. And when we're really in a dry environment, sometimes they don't ever get pollen. So we see that in some fields, especially worse in some of the ones that have had some of the most stress. So that's kind of what things look like out here in some of the corn. One last map I was going to show, I think is kind of interesting. We've got these weather stations around our territory. We've got one by Ocheyedan and one by Dune. We've got moisture sensors down at 12, 24, and 50 inches. And they're actually out in the field away from the weather station, so they're actually out with a crop growing above it. It's kind of interesting if you look at this. This is actually soybeans in this field this year where these sensors are, but it is kind of interesting. You can see when those soybean roots got down to those those sensor levels and started pulling moisture out, because we weren't getting a lot, you know, rain above that, so it was pulling subsoil moisture out. And it is kind of interesting to see. You can see the time frames. You can see when it got to the 12-inch soil depth, and you can see that moisture level start to drop off more rapidly. You can see the 24 and then the 50-inch, and you can really see how it's really started to pull moisture out of that, you know, that bottom 50-inch sensor here the last part of the season. So I would guess if this was corn, you'd see that probably be even a little earlier and a little bit more drastic as far as how much moisture it's taking. A good corn crop probably takes 4 inches more soil moisture than soybeans do, so I think it would obviously been a more severe situation in how that moisture was being pulled. But just thought I'd touch on that, just kind of give a status of what I'm seeing, why I think we're seeing what we're seeing, put some numbers to the, you know, give a little context to where we're at. So with that, that's this week's Field Friday segment, and we'll see you next week.